In this video, we'll explore how you can build an AI-powered tool that lets users talk to your business data and get answers to their questions. Let's go. Hey folks, welcome to Build with Google AI, where we explore how you can build practical solutions with Google AI technology. As a developer, there's a good chance you've been asked to dig into your organization's business systems to answer questions like, how fast are we running out of the materials for this product? Or what services are selling well in that region? These questions lead to more questions, and suddenly your afternoon or week is gone as you write more and more database queries and API calls. But what if you could use AI technology to let your non-coding colleagues answer their own questions without you having to write code every single time? Well, one of my colleagues has built a project with Google's Gemini AI that helps your colleagues get more answers and lets you spend less time writing one-off code. The SQL Talk project is an application that uses Google's Gemini AI to translate your questions into programming interface calls and turn the retrieved data into plain language responses. Here's a quick demo. The project provides a chat interface for interacting with a database of an imaginary e-commerce business. You use it by asking a question. What's in this database? The application takes your question and uses Gemini's function calling feature to turn your question into programming code. In this case, it writes code in structured query language, or a SQL query, to access information in the database. The application executes the generated queries against the database, gets the raw data, and then uses the Gemini model again to translate the data into plain language. Let's ask a more interesting question. What are the top product categories by revenue? I got a pretty good answer, but it didn't list the actual revenue. So I can change my question to ask for that detail, or I can look at the queries it made and see the revenue values in the retrieved data. What's kind of mind-blowing about this application is that the Gemini AI can turn my question into a code implementation and then turn the raw data it retrieves into an answer I can easily understand. What's even more exciting is that this approach is not just limited to SQL queries. You can adapt this application pattern to create a natural language interface to almost any business system in your organization, as long as it has a programming interface. I'll get to that a little later in the video, and in the meantime, let's talk to the builder of SQL Talk and have them explain how it works. Okay, I'm joined today by the builder of the SQL Talk project and member of the Google Cloud Developer Relations team, Chris Overholt. Thanks for being here.
Hey, Joe. Yeah, good to be here.
Okay, so the SQL Talk application is pretty cool, but why would you go to all this trouble? We already have programming interfaces and SQL query language to go get data out of business systems. Does having AI as a front end actually help you do a better job there?
Yeah, no, it's kind of interesting. This is not the first time someone's developed an application to talk to SQL. But what's happened in the industry is that generative models like Gemini have really unlocked the potential for developers to create things that let business users interact with systems. So you think of it like generative AI, we had all the pieces there in place, but generative AI helps us take natural language and talk to API programming interfaces, and then go back so that we can explain all of that in plain language to end users. So think of it kind of the missing piece that helps us with these kinds of workflows and just helping more people interact with services without having to know all of the schemas and API syntax and all that stuff.
Okay, so next question. How does the SQL Talk project actually work?
Yeah, it's a good question. It's actually pretty beautiful in its simplicity. And so it uses a feature within Gemini that is tuned to output structured data and work with functions and tools. So what that all means is that at design time, the developer will specify and declare functions. You can think of these like tools. So in this application, there's 4 different tools. There is a tool to list a data set in BigQuery or get a list of tables. And then there's a 4th tool, my favorite one, that actually generates a SQL query on the fly. And for the parameter specification to Gemini, we told it, please generate SQL to answer the user's question. So it's kind of a neat use of generative AI and parameters. And then at runtime, the way it works is that an end user will ask natural language something about information that would be in the database, and then Gemini is going to pick the function that it believes will answer that question, and it will actually output a function call for you to make externally. So in your application code, separate from Gemini, you can use whatever API client you want. You can use Python, REST APIs. You could even use SOAP XML if you wanted. So we give developers that freedom to do that in function calling. And then the last step in that is to return the API response to Gemini, who's then going to answer the original question with the API response from the external system and kind of synthesize all that back to natural language. So the loop here for the end user is natural language to BigQuery commands, SQL queries, back to natural language to answer the question.
Okay, so next question. If I want to extend this project, how do I go about doing that?
Yes, very good question. This application and the way it's designed and function calling in Gemini are very extensible and separable. So all of the application code for SQL Talk is less than 200 lines of Python. That includes function definitions and all the logic and the UI. So you can basically take these components and say, instead of, we talked about generating SQL, but what this is really doing is making API calls on the back end. So some things that you might do to extend this are, maybe you are using a different database. So you're using a different SQL database, different NoSQL, and you could change this to talk that dialect and communicate with that API. Or you might have document repository. So moving away from SQL databases, maybe you have hundreds of thousand documents in your company's repository. You could use this to make API calls, return content from those documents, and give answers. Or you might have a CRM system with live customer information. So you can now ask questions about customer orders or customer statuses, and function calling would give you function calls to make via an API call to the CRM system, get back live data, and then translate that back to natural language. So very extensible by nature.
Great. So last question. From what you've explained, you're using an existing model to do this and not building any new AI models. So does this really count as an AI development project?
Yeah, absolutely. So most developers have been working with generative models through prompting. So prompt engineering, prompt tuning. This one's a little bit different, and you're absolutely right. We're not training a new model. We don't have to fine tune a model. And that's actually intentional. For these kinds of applications, you can actually do everything at runtime with these models. They're very powerful, very generalized. So there's two things. For the developer, they'd be using a specific part of the Gemini API for function calling. And this gives them basically a mechanism to translate natural language to API calls. And that's really powerful to plug into your application logic. For the end user, it means they don't have to be an AI developer at all. They're just interacting in natural language with something that is using AI to translate that to an API call, making an API call, and coming back. So it really up-levels both the AI developer, because now you have a structured API to work with, as well as the end user. So now you have a whole bunch of more people that can interact with your business systems live without having to be an AI expert at all.
All right. Well, thanks for talking to me about the SQL project today.
Yeah, thanks for having me.
It's coding time. Let's look at how you can extend the SQL Talk project to create your own AI-powered data exploration features. Don't worry about taking notes. There's a detailed tutorial linked in the description. Here's the code for the SQL Talk project. The main parts of this application are the function call definitions, the user interface, and the logic for making the function call requests against the actual database APIs. The main way to extend this application is to add a function call definition and then map that definition to a corresponding API call. Let's say you want this application to be able to answer questions about queries or jobs being run against the database. To do that, first you need to create a new function declaration. This declaration defines a general programming interface for the Gemini AI model, which is in a specific format, including the name of the function, what the function does, and the parameters that it can use. We're going to keep this really simple and just explain the function's purpose and not allow any other parameters. Next, you need to add this function declaration to the list of tools for the Gemini model. The last thing we need to do is to tell the SQL Talk application how to execute the list jobs API if the Gemini model requests it. So we add this code to call the database API and get a list of the last 10 jobs. To keep this really simple, we'll just get the job IDs from the API response. A little further down, you can see that the application takes a response from the API calls and makes an additional request to the Gemini model to summarize the data in plain language. Now we just have to deploy this updated code to Google Cloud and test it out. And we'll speed up this operation through the magic of editing. Great, our code is deployed. Let's try it out. List the latest query jobs. Now, this answer isn't very interesting, but you could do a lot more with this function call by pulling more data out of the list jobs API response, or by creating an additional function call to get more detail on individual jobs. You've probably got some even better ideas. So let's wrap this up. And that's all the time I have to tell you about this AI-powered data exploration project, SQL Talk. Thanks to my guest, Chris Overholt from the Google Cloud Developer Relations team. Links to the code project and a detailed tutorial on how to extend SQL Talk are in the description. If you get some new functionality working, let us know in the comments. Thanks for watching. I really hope this video helps you build your own AI-powered data exploration tool and helps you and your non-coding colleagues unlock the value of your organization's data. So keep learning, keep building, make something great. We'll see you again soon.